Osprey, a millimeter wave approach to tire wear sensing. Tire wear is an important problem for automobile safety and performance. Our approach is to use existing millimeter wave radars for this task. The radar blasts radio waves at the tire and observes reflections just like a laser. This allows for continuous sensing while being resilient to debris and without using any electronics in the tire. We use two main techniques. First, the natural rotation of the tire allows us to use synthetic aperture approaches to achieve millimeter resolution. Second, the coated metallic strips in the groove provide resilience to debris. Our setup is as follows.
Hi everyone, my name is Alan Zhang, and let me briefly introduce our work, mobile volumetric video streaming enhanced by super resolution. Point cloud volumetric videos enable novel applications due to their truth-read nature. However, streaming these videos is extremely bandwidth demanding. In this work, we apply 3D super resolution to enhance volumetric video quality, striking a trade-off between the network resource and the client-side computation capability. We train a DNSR model to learn how to reconstruct high-resolution details from the given low-resolution contents. And we are developing Volume SR, the first system enhanced by super resolution for streaming high-quality volumetric content wirelessly to commodity mobile devices. We apply both system and algorithmic level optimizations to make the DNSR model work on commodity mobile devices. If you are interested in our work, please refer to our poster and feel free to ask questions. Thank you.
Network-level collaboration among personal mobile devices is helpful to better utilize available network resources, such as improving the throughput through bandwidth aggregation, overcoming per-device rate limit, as well as extending the wireless range. To this end, we propose MPBond, a distributed multipath transport system for efficient network-level collaboration. Key design decisions of MPBond include cross-device connection management, purpose-set subflow split with buffering, pipe-aware multipath scheduling, as well as a flexible policy framework. We implemented MPBond on Android devices to demonstrate its benefits.
Hi, I'm Navid and I want to present our poster, a benchmark for event race analysis in Android apps. Event races are a common concurrency bug in Android. An event race consists of two events accessing the memory location without any specific order, and one of the accesses should be a write access. Therefore, the behavior of the code depends on the order of execution of these events. In this example, the write scenario throws a null pointer exception. In this work, we study and characterize event races and created a micro benchmark of event races. For example, this application on the right has two event races which use thread and handler as their concurrency API. Bench races consisted of 34 application and 60 potential event race bugs. All of the source codes are publicly available on GitHub.
In this work, we seek to build a warning system under the pandemic of COVID-19 using near-field communication technology. We present no-face contact, which promptly monitors users' wrist position and raises alerts when they attempt to touch their face. No-face contact has an NFC reader at the user's hand, for example, a smartwatch around the wrist, as well as an NFC tag close to the user's face, for example, attached on earrings or legs of glasses. Our proof-of-concept experiment reports an average communication range of 8.07 centimeters, with a maximum distance of 14.5 centimeters. This covers a wide range of face-touching poses. We also carry out a simple toy example using NTAG215 sticker tag, PN532 commercial NFC module, and Arduino Uno. We hope that this work can help raise public attention to improve personal hygiene over diseases that spread like COVID-19, as well as encourage core NFC adoption in future wearables.
Does ambient RF energy suffice to power battery-free IoT? Ambient backscatter communication refers to using ambient RF energy for an IP tag's power requirements. Lots of work has already been done in this space using LoRa, FM, and TV-based stations. However, there are some important questions which are left unanswered. Is ambient RF power sufficient to power a tag ubiquitously? Also, what are the limits on the technologies which meet these power requirements? We answer these questions by performing a feasibility study in the real world. From our trace-driven simulation, we find that in most geographies, the effective coverage available for ambient backscatter is poor. Even if you use different technologies, the results are the same or may become worse for technologies like cellular. There can be many possible solutions to this problem. Surveying the area before deployment, creating friendly FCC regulations, and innovations in tag hardware design. Find out more at the link given below. Thank you.
This video introduces Vulcan, a state-aware fuzzing tool for Wear OS ecosystem. Over the last decade, wearable devices such as eyewear, earwears, fitness trackers, and smartwatches have grown in popularity. This growth has been driven primarily by fitness tracking and health monitoring use cases. Even though most of these devices have limited functionality, devices like smartwatches provide many features, often augmented by third-party applications. Since these devices are being used for health purposes and other critical tasks, their accuracy and robustness can give rise to safety concerns. Therefore, it is important to thoroughly evaluate the reliability of its ecosystem. We present Vulcan, a state-aware fuzzing testing tool that can automatically and efficiently evaluate the robustness of wearable applications. Vulcan works in two phases. In the offline training phase, the tool learns the finite state machine model of the app, while in the online phase, the tool steers the app to the vulnerable states and injects messages or intents in a directed manner. Learn more about Vulcan in our website.
What we're trying to do is deduplicating client-server communication. Here's a simple case of deduplicating Android applications. However, the future directions can be much more useful than a simple case of deduplicating a single file. One interesting question would be whether or not we can apply this to floating point data to deduplicate neural networks, similar to a technique like quantization.
Hi everyone, welcome to our poster. In recent years, air pollution impacts our health greatly. To monitor air pollutants, local air sensors has been deployed to develop a large-scale and high-density sensor network. But local sensor suffers from data reliability and data quality. Quality audit of deployed sensors is essential for ensuring data quality, and each sensor must be visited, inspected, and adjusted by professional technicians regularly. However, visiting all sensors in a large-scale network is time-consuming. So, is it possible to visit representative sensors only? Welcome to our poster, Key Sensor Discovery for Quality Audit of Air Sensor Networks. Thank you.